2-8, dividing integers, and in this lesson you learn how to divide integers. Okay, let's remember that you use counters in lesson 2-7 to understand the rules for multiplying integers. We actually didn't do this, okay, but let's just look at this example and let's see how this relates to dividing integers. You can also use counters to model division. The diagram at the right shows 12 negative counters separated into 4 equal groups. Counting the number of counters in each group shows that negative 12 divided by 4 is negative 3. So this is a basic division which you learn probably in 3rd grade, 4th grade. Okay, then when you have negative 12, in this case you have 12 counters and you divide them into 4 groups, you end up with 3. But modifying this problem, instead of just 12, you have now negative 12 counters, and if you divide it into 4 groups, you end up with negative 3. That's what it's trying to show. Okay, and let's see how this relates when you're trying to divide integers. So you could also find negative 12 divided by 4 by looking for a pattern. We know for a fact that 4 divided by 4 is equal to 1, and we also know for a fact that 0 divided by 4 is equal to 0. And if you look at the pattern from 1 to 0, you're subtracting 1, and then you're subtracting 4 on the dividend side. Okay, so the divisor remains the same, which is 4. The quotient, you're subtracting 1. The dividend, you're subtracting 4. If you follow that pattern of subtracting 1 all the way, okay, and subtracting 4 all the way, so this becomes negative 4 divided by 4 equals negative 1. And continuing that pattern, this becomes negative 4 plus negative 4 will give you negative 8 divided by 4 equals negative 2. And still continuing that pattern, this becomes negative 12 divided by 4 equals negative 3. Okay, and if you think about it, what is the next division sentence in the pattern? Obviously, you will add negative 4 to negative 12, which will give you negative 16. 4 remains the same, and this becomes negative 4. So that's negative 16 divided by 4 equals negative 4. So, following the pattern, we know that you have a positive divided by a positive will give you a positive. 0 does not have a sign. Anything divided by 0 will always be 0. So you have now a negative divided by a positive will give you a negative. Negative divided by a positive will give you a negative. So in the example above, right there, the dividend is negative and the divisor is positive. Okay, and let's try a case when the signs are reversed. Okay, let's see if we can solve f equals 12 divided by negative 4. Now the divisor is negative. Okay, and if we use a calculator, now using a calculator, you will end up with negative 3. Okay, so 12 divided by negative 4 is negative 3, and it seems that if the dividend or the divisor is negative, but not both of them, the quotient will always be negative. Which brings us to the rule on dividing integers. Dividing integers with different signs. The quotient of two integers with different signs is negative. So whenever you divide two integers and they have opposite signs or different signs, okay, the result, the quotient will always be negative. Okay, let's take a look at example number 1. Solve each equation. Negative 34 divided by 2. You have a negative divided by a positive. Just like in multiplication of integers, when you have that, the dividend and the divisor have different signs, the quotient will certainly be negative. So the answer would be negative 17. In the same manner, remember that the fraction bar indicates division. Okay, the dividend will be the numerator, divisor will be your denominator. So you have your divisor being negative, the dividend and the divisor still have different signs, the quotient will still be negative, so y equals negative 14. Okay, you already know that the quotient of two positive integers is positive. 21 divided by uh, 3 is 7 from your basic division. Both the dividend and the divisor are positive. Okay, so the quotient is positive. So you have the dividend and your divisor being positive, the quotient will be positive. Okay, now what if, how would you solve z equals negative 27 divided by negative 9? Okay, now you have a negative dividend and a negative divisor. Again, let's look for a pattern. Okay, so from the pattern we had last on the previous slide, 18 divided by 9 will give you a negative 2, because again, from following the rule, you have a positive divided by a negative, that will give you negative 2, and we continue that pattern. If we continue that pattern, okay, when you have 9 divided by negative 9, okay, will be equal to negative 1, again from the previous rule. Now let's look what's happening to the pattern. The quotient, you're simply adding 1, okay, and the dividend you are dividing by, you are subtracting 9. Okay, so here you're subtracting 9. Okay, and on the quotient side you are adding 1. Okay, following that pattern, this now becomes 0 divided by negative 9 will always be 0. Again, we're still following the pattern. Continue to subtract 9. That will become negative 9 divided by negative 9 equals 1. Okay. Negative 18 divided by negative 9, which will give you 2. And finally, negative 27 divided by negative 9 will give you 3. Okay. So the solution to negative 27 divided by negative 9 is 3. This pattern suggests the following rule, very, very similar to multiplication, that the quotient of two integers with the same sign is positive. Just like multiplication, the product of two integers with the same sign is positive. So you can actually interchange the quotient and product, okay, because they will have the same rule. Let's take a look at some examples. Example number 2, solve each equation. M equals negative 40 divided by negative 8. Okay, again you have your dividend and your divisor having the same sign, so the quotient should be positive. So negative 40 divided by negative 8 should give you a positive side, positive 5. You have 90 over 15, both the dividend and the divisor are positive, they have the same sign. Obviously this the quotient is positive, which will give you 6. Okay, let's connect this to algebra. You can find the value of expressions involving division by using the same rules as division with integers. Again, we go back to the word evaluate, and in evaluate, if you want to find the value of, 2 steps you need to take, 2 steps to consider: substitute and simplify. Okay, so in the first step, we need to substitute the value for C and D. So we have C is equal to negative 9. CD divided by negative 3. We are replacing C with negative 5 and D with negative 9. Okay. And the next step after that would be 45, because a negative multiplied by a negative will give you a positive. Okay. And then simply bring down negative 3. You now have a positive divided by a negative. Okay. So when you have that, the product would be negative. So the quotient of 45 and negative 3 is negative, so it's negative 15. So negative 45 divided by negative 3 will give you negative 15. And let's do the last example, obviously a word problem. Okay. People in Duluth, Minnesota find ways to enjoy their lengthy cold spells. Energy providers use degree days to estimate the energy that will be needed for heating in these cold days. The degree day number indicates how far the day's average temperature was above or below 65 degrees Fahrenheit. So they use this formula, D equals 65 minus H plus L all over 2, can be used to find the degree days. In the formula, D represents degree days, H represents high temperature of the day, L represents the low temperature of the day, and if D is positive, okay, it represents heating degree days. If D is negative, okay, it represents cooling degree days. Okay, if the high temperature in Duluth was negative 2 degrees and the low temperature was negative 16 degrees, find the degree days. Okay, to solve this problem again, we use the formula D equals 65 minus H plus L plus 2. We evaluate the formula, we substitute the values for H and L. High is negative 2, low is negative 16. So we substitute negative 2 and negative 16. Okay, order of operations, okay, that should not have shown there, but we already know the answer. So negative 2 plus negative 16 will give you negative 14 divided by, negative 18 divided by 2. Okay, that will give you 65 minus negative 9. And going back to our rule, when you're subtracting integers, when you are subtracting, you're actually adding its opposite or adding its additive inverse. You remember that? So this becomes 65 plus 9. That will give you 74. And that's the reason why you have 74, okay, as your degree day. Since it's positive, it's a heating degree day. Once this becomes negative, then it becomes a cooling degree day. Okay, and that's how you apply division of integers to be able to solve this word problem. And lesson's done. So on Google Forms, type a summary of what you've learned by responding to the objective of the lesson, and type a question you might want to ask in class about this lesson. Thank you.